Welcome to our physics lectures in Learn Physics and Problems. Today our topic is acceleration. We will start with an example. Let a car is moving on a road in a constant time interval. It covers different displacements. We will check its speeds. So we see that its velocity is changing. The car is speeding up as the velocity is increasing. So we define it when delta V changing or increasing. It is called acceleration. So we define it acceleration is equal to rate of change of velocity. We represent it by A is equal to delta V over delta t. Here delta V is the change in velocity, delta t is change in time. For understanding between constant velocity and changing velocity, we take these two figures again. In the first, we already described the at a constant time intervals, it covers different displacements. In the second graph, at constant time intervals, its change in displacement is the same. So its velocity is constant. So delta V is 0. Now we define acceleration A is equal to delta V over delta t. Delta V is equal to V2 minus V1 over t. Delta t is normally represented by simple t. V2 is the final velocity, V1 is the initial velocity, and t is equal to delta t. Now we represent V2 as a V, V1 is equal to u, which represent initial velocity and final velocity. Above equation will become acceleration A is equal to V minus u over t time. Its units are meter per second square. As V is a vector quantity, so acceleration is also vector quantity. Acceleration has two components, magnitude and direction. Here magnitude, speed represents the magnitude. For example, if a body moves around a curve or in a circle, its direction is continuously changing. Though its speed is constant, even then it has acceleration, as shown in the pictorial graph over here. As the direction is continuously changing, so it has a constant acceleration. It has acceleration. Now from above equation, A is equal to V minus u over t, we deduce how many parameters we can calculate. We can find acceleration, that is, if we know final velocity, initial velocity and time. We can also calculate final velocity, initial velocity and time if other parameters are known. For example, if we want to find final velocity and know acceleration, initial velocity and time, then the above equation 1 will become as V is equal to u plus at. If we want to find initial velocity and no other parameter, then the above equation will become as u is equal to V minus at. Similarly, if we want to find time t, the t is equal to V minus u over t. These are the different formulas of the above equation which can be used to deduce or find any parameter. A car accelerates from start and reach a velocity of 80 meters per second after 6 seconds. Calculate its acceleration. So it has initial velocity is 0, final velocity is 18 meters per second, and it take time 6 seconds. So acceleration A will be V minus u over t. 18 by 6 is equal to 3 meters per second square. There is another term, that is deceleration. Deceleration is opposite of acceleration. Acceleration is a speeding up when velocity is changing. Deceleration is opposite, is decreasing or reducing the speed. Or when we use brakes on a car, it's going to stop. So that is the deceleration. Its formula and units are the same as acceleration, but it shows comes with a negative sign to represent that its deceleration.